Hello, welcome to this video about the Lighthouse project in RAJKOT. In this video, we will look at how to improve thermal comfort, like we already did for the first Lighthouse project in Chennai. In the first part of the video, I will explain some more basics on thermal comfort. We will have a deeper look in human energy balance. In the second part of the video, we will look specifically at the Lighthouse project in RAJKOT and see what measures we can take to increase the comfort in the room. Let's start. In lecture 1.5 on comfort assessment in Chennai, we have already learned that basically 6 factors have influence on thermal comfort: humidity, airspeed, radiant temperature, air temperature, metabolic rate, and clothing insulation. Now let's look a little closer at the human energy balance. For the full functioning of all organs of the human body, the core body temperature must be maintained at around 37 degrees at all times, irrespective of climatic conditions. This is ensured by the thermoregulatory system of the body, which maintains the core body temperature through measures such as vascular constriction, vascular dilation, cold shivering, or sweating. In order to ensure well-being in the prevailing room climate, the human body's heat balance must be balanced. This can be described with the following heat balance equation. Let's go through it in detail. H corresponds to the internal heat production of the human being. From this, 4 values are subtracted. ED is the heat loss by water vapor diffusion through the skin. ESW is the heat loss by evaporation of sweat on the skin's surface. ERE is the latent heat loss via respiration. And last, L is the heat loss through dry respiration. The result corresponds to the value K, which is the heat transfer from the skin to the outer surface of the closed body, and which can also be divided into R and C, where R is the heat loss via radiation from the outer surface of the closed body, and C is the heat loss via convection from the outer surface of the closed body. As can be seen from the equation, the human heat balance is an equilibrium when the heat production is equal to the heat output. So much for the basics of human energy balance. Now let's go back to our Lighthouse project in RAJKOT and examine which construction variants can have a positive influence on the thermal comfort of the resident. Let's start by taking a closer look at the climate in RAJKOT. As you can see on the right side of the slide, RAJKOT is located in the yellow area, in the yellow climate zone in India, which means that it is in the semi-arid area. On the left side, you can see more information about the average minimum and maximum temperature, precipitation, and relative humidity. We see that through the year, temperatures are quite high. Relative humidity is high in the summer month and lower in the rest of the year. The temperatures cool down considerably during the night compared to the daytime temperatures, even in the summer. We can use this temperature difference specifically for comprehensive ventilation strategies to improve comfort. We will come back to that later on. From November to February, relatively low temperatures are reached, which will require some heating. However, the biggest challenge in terms of thermal comfort is again avoiding summer overheating. Here we have again tested various measures and calculated how they affect occupant comfort. On the right side, we see again the simplified representation of the layout of the buildings in RAJKOT. We have again calculated for the specific floor plan and the monolithic concrete structure how the indoor comfort depends on the outdoor climate. At the top right, you can see how many hours over the entire year are likely to be rated as best, good, acceptable, and unacceptable condition by the users. Comparing these values allows us to compare different variants against each other. Here we have again first considered the reference case with active cooling. Not surprisingly, we always have at least an acceptable climate here. In most cases, it is even rated as the best climate. The situation is completely different if we do not use active cooling and do not apply any other measures, such as shading or special ventilation strategies. Here, unacceptable climatic conditions occur in the interior for almost 2000 hours, because the interior overheats mostly, especially from April to June, but also again in October. The acceptable indoor temperatures are clearly exceeded. Let's now look at how we can improve comfort without the use of energy-intensive active cooling. First, we want to take advantage of the temperature difference between day and night. In climates where there is a relevant temperature difference, it usually makes sense to keep the building closed and the windows shaded during the day and to ventilate at night. In this case, we have not yet taken into account shading, but we have increased ventilation during the nighttime. We see that the course of the temperature is very similar to the previous case, without night ventilation. However, this very simple measure has at least reduced the number of unacceptable hours by more than 300 hours, compared to the previous case, which is about 17%. However, it is important to make sure that the increased night ventilation takes place only in the warm months. Otherwise, the room would cool down too much in the cold season, which in turn would increase the number of unacceptable hours. Here we have calculated with increased night ventilation only from March to October. As a final case for the building in RAJKOT, we have considered here several measures combined with each other. Here we have calculated the indoor climate for the case that there is no active cooling, a highly reflective paint is applied on the outside, the outer wall is insulated, and an external shading is installed in front of the windows. You can see all the measures here on the right side. In addition, we also considered night ventilation in summer in this case. Without these measures, the number of unacceptable hours was about 2000. With these measures, we were able to significantly reduce them to about 900 hours. Thus, we were able to increase the comfort significantly even without active cooling. Here we see again the results of the evaluation of occupancy hours in the overview. On the far left, the case with AC, which leads to overall comfortable conditions. Next to it, we see that about 30% of the time there are no acceptable conditions in the building if we do not use active cooling or any other specific measures. In comparison, we see that increased night ventilation in the warm months can reduce the uncomfortable proportion, at least somewhat without much effort. Here on the right side, we see the most effective is the combination of different measures, such as shading, night ventilation, insulation, and highly reflective surfaces on the outside of the building. This is shown on the far right. The red share can be reduced to less than half compared to the case without measures. To conclude this unit, I would like to summarize the main findings once again. In the first part, we have deepened the basics of thermal comfort. we have looked at the equation for the human energy balance and which variables have an influence on it. In the second part, we looked at the effect of various measures on the indoor climate and comfort, specifically for the lighthouse project in RAJKOT. We learned that we can take a very easy advantage of the temperature difference between day and night to improve comfort with the help of specific night ventilation. A combination of different measures, such as shading and night ventilation, was much more effective. In the case of night cooling, we must take into account that it only takes place during the warm month. In the cold months, the room would otherwise cool down too much. With this, I say goodbye for this video. Thank you for your attention and see you next time when we will have a look at the comfort in the lighthouse project in Lucknow.